Okay, this is very nice example to understand how we'll do so. So it is called step down approach. Earlier it was step up approach. We started with the lowest order polynomial a1z, then we moved ahead with a2z, then further a3z was calculated. Okay. A1z first calculated. First we used a0z, that is always equal to 1. Then a1z is known. Okay. Then a2z calculated. Then a3z calculated. Okay. And at the same time, b1z, b2z, and b3z can be calculated from the reverse polynomial concept. Okay. Bz is the reverse polynomial of az. Okay. Then so this concept was used to convert the lattice coefficients to direct from filter coefficients. Okay. Now for the process, if direct from filter coefficients to lattice coefficients, we use the step down approach. Okay. That means initially we will consider most highest polynomial, highest order polynomial, then we go to the lower order polynomial. So here A3z is given. Okay, determine the lattice coefficients corresponding to the FIR filter. With system function this A3z is equal to 1 plus 13 by 24 z inverse plus 5 by 8 z to the power minus 2 plus 1 by 3 z to the power minus 3. How we will calculate? So these are given as what? These are coefficients. You see how it is done. So first we know that K3 is equal to alpha 3 3. It is always there in the lattice structure that the most highest direct from coefficients alpha m. Okay, you can see here it is written that Km is equal to alpha m always. Okay, most highest coefficient is always equal to this. Okay. So we started with that K3 is equal to alpha 3 3, that is equal to 1 by 3. Then from there we calculate B3z. B3z is what? It is the reverse polynomial of A3z. So we just 1 by 3, B 5 by 8, 13 by 24, and z to the power minus 3 right. Okay. Then step down relationship in this with m is equal to 3, then we calculate a to z. A to z is, we know a3z, so a3z, from a3z we have to go to the lower order step down. So it is a to z is equal to a3z minus k3 b3 divided by 1 minus k3 square. Both A3 and B3 is known. B3 is calculated from A3 itself. So from there we get as 1 plus 3 by 8 z inverse plus half z to the power minus 2. So this is actually what? This is actually the polynomial of B to Z, A to Z. So in that we get Km, a K2. The most highest order is K, this is K2, which is alpha 2 2. Okay, so this is equal to half. So what we got, alpha 3 3, we have got 1 by 3. Then we get alpha 2 2, that is equal to half. Okay, then and B to Z, then we again reverse it, take the reverse of the polynomial of A to Z. So again from there we calculate both from both A2Z and B2Z, we calculate A1Z, that is step down approach. So it is 1 plus, it is coming to be 1 plus 1 by 4Z. So it is actually K1, that is most highest order polynomial alpha 1 1, that is 1 by 4. Okay. So how many coefficients we have calculated? Direct from coefficient, that is alpha 3 3, alpha 2 2, and alpha 1 1. These three you have calculated. Okay. So this is a method to convert the direct from lattice filter coefficient, lattice coefficients to determine the lattice coefficients corresponds to the FIR filter with system function this. So what we got, that this is given in terms of alpha coefficients, and it is written that it is given in terms of alpha coefficients. Okay. Uh, any expression actually that it should be mentioned that what coefficient it is. It is lattice coefficients or direct from one coefficient. So it is in direct from one coefficients. Okay. So the most highest order direct from coefficients is actually the lattice coefficients. So from that concept, we have determined that K3 is the most highest coefficient alpha 33, K2 we have calculated, and K1 we have calculated. So for the third three-stage FIR filter, we have calculated the lattice coefficients from direct from coefficients in this example. And in the previous example, we have calculated the lattice coefficient, the direct from coefficients from the lattice coefficients. So in this example, you see the difference. You see the difference is that it is written in terms of only the coefficients, lattice coefficients K1, K2, K3. And from that, when you will calculate the polynomial, okay, you have to follow the step up approach. Okay, first you calculate A1Z using this formula A0Z plus this one K1Z inverse B0Z. Then once you get A1Z, then you will get B1Z. Okay, A1, B1, you have got it. Then if you get the expression, then you will calculate, you will be able to calculate the alphas direct from filter coefficients. Okay. Similarly, go for the second order higher second stage. From the second stage, using the direct lattice form coefficients, you convert it into general expression. And in the general expression of the polynomial, from there you write it as this one. Okay. Alpha to the direct form coefficients. So this is the method to convert the lattice coefficients to direct form coefficients. And this example we have used in for direct form coefficients to lattice coefficient. And in the polynomial, it is directly the expression is given. Okay. But in that case, K1, K2, K3s are given. So up to this, you just go through it, and I will upload this PPT. Okay, this is slightly updated. So do you have any doubt? Anybody?
No, sir. We'll go through the PPT and then pass.
Okay. You may leave now if you have any further doubt.
Thank you, sir.